Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi everyone. Today we'll be looking at chapter 10, which is normal distribution. Normal distribution is a part of probability distribution that we learned in chapter 9. What we have to learn in this chapter is to know how to calculate normal distribution using normal distribution tables and how to calculate raw data using the normal distribution formula. So I suggest the key thing is to memorize the formula and understand its components so that you could apply the formula to any given scenario, because your revision kit, if you look at it, they have given questions in a way that they ask around the normal distribution formula. Alright. So we will be covering normal distribution, the standard one, and then z-scores, and then finally the central limit theorem. So this section we have covered at last in chapter 9. So I will skip this and let's start from here. As I said, normal distribution is a type of probability distribution applied to continuous variables such as distance and time. And they can be applied to discrete variables as well. Normal distribution curves as a diagram, they are bell-shaped, okay? And they look like this. They are symmetrical. You can write down or make a note of the word symmetrical next to this picture. That means let's first understand this curve. The horizontal x-axis is a set of values and the vertical axis is the probability distribution values, the frequency density they say, the proportion, okay? Basically it is the probability. However, what the symbol like the U shape means, we learned that this is called or represents the mean average, and it's another name for this symbol is called mu. Okay, so because that what it represents here is that the mean is right in the middle of the data and there's an equal spread of data around the mean. Alright, so area under this curve is equal to 100% of all the probabilities. Basically, it's equal to a probability of 1. Okay, it's equal to a probability of 1. Remember that. Area under the graph, that means see the cursor, whatever under this portion is equal to 100% of all probability. Again, they mentioned a normal distribution curve is generally symmetrical and bell-shaped, and it has a mean pronounced as mu. The area under the curve totals exactly 1, and area to the left of mu is equal to the area to the right of mean, which is 0.5 on each side. So this side is 0. So this side is 0.5 and this side is 0.5. 0.5 plus 0.5 is equal to 1, which is the area under the graph. Okay. So why normal distribution is important? Because in practical application, many probability distributions are close to normal distributions. Okay? That means it can be used as a tool in making business decisions with the links to probabilities. It's one another business decision making tool. Okay, let's learn what's standard normal distribution. For any normal distribution, the dispersion around the mean can be measured exactly in terms of standard deviation. This we learned, where we learned that the standard deviation formula will be applied, and we will get the answer which will represent how far the data is close to the mean average or far from the mean average. Okay. So they say if you get a standard normal distribution, its mean will be 0 and standard deviation will be 1. Okay. So in the exam they might ask in an MCQ, what is the mean and standard deviation of a standard normal distribution? Then you should say its mean is 0 and the standard deviation is 1. Okay. So the reason is because the entire frequency curve, that means what's the curve they are referring to? This curve. Okay. Represents all the possible outcomes. Right? So, and the curve is symmetrical. So 50% of occurrences have a value greater than the mean and 50% have a value less than the mean. So basically that's why they say mean should be 0 and standard deviation is only 1. Okay. So yeah. Now they are showing an example of 68% of frequencies having a value within one standard deviation either side of the mean. Now, it doesn't have to be 100% totally. It can be 68% also. But if it's symmetrical, it will be equally split to both sides. Do you see this equal thing? Unfortunately, I cannot highlight here. But if you see, observe my cursor. This side is 34%. This side is 34%. This side has a standard deviation of 1 and this side has a standard deviation of 1 and the mean is 0. So you see, what matters is not the percentage of the probability but the way it's presented in the graph or the curve. So no matter what, since the curve is naturally symmetrical, both sides will be equal. That is the learning point we must take home. So if it's 68% of frequency is represented in the curve, that means half of it is 34%, which will be on the left side of mu and 34% on the right side of mu with a standard deviation of 1 each. Okay. They have given another scenario. Okay, here 95% of the frequencies occur in the range 1.96 standard deviation from the mean. Okay, now here's where a new learning point comes. That is, you have seen now when it was 68%, it had one standard deviation. But when it came to 95%, the standard deviation increased to 1.96. Why is it? Well, it's because of the normal distribution table and the normal distribution formula. Okay. So in the exam, You're not supposed to straight away or make guesses on what the standard deviation would be. Alright? Because you need to make a logical approach to answer the MCQ. They will not let you make guesses. So you shouldn't be saying, but definitely you can make a guess when there's 100% frequency. Because anyway standard deviation it will be 1 and the mu will be 0. But for other instances, we have a formula to apply. So let's see what the formula is and how it works. And as they mentioned, they will give the distribution table in the exam as well. So that's good. Okay. So the table represents relative dispersion of frequencies around the mean, which is the standard deviation shown as a proportion of the total population. Okay. That means the standard deviation like divided out of the total population is the normal distribution. Because they want to show the goal of normal distribution is to show how the numbers have distributed around the mean average. Because what we learned in standard deviation was how far the numbers were distributed from the mean. Isn't it? So normal distribution is a better way of checking it because it measures the standard deviation against the proportion of the total population. Right? So, okay. Alright, so this is how it presents itself. So the area under the normal curve between the mean and the point Z, okay, Z, this side, is the standard deviation greater than the mean. That means, see my cursor, this area is where your standard deviation is more than the mean. Obviously no, because this side, if you go this side, the numbers are increasing. So we will have a higher standard deviation value more than this mean value. Okay. And this side, the standard deviation is less than the mean. Because obviously the number line starts from here, see the cursor, from here to it increases this side. Right? Okay. Now, this is the formula you got to memorize. Make a note of it. So they say Z, which is this Z, okay, the Z that you see on the graph, is equal to any value of X given, right, minus the mean divided by the standard deviation. Alright guys, so what we've learned and seen so far is just the presentation of a normal distribution curve. But we don't know exactly what the curve represents, what are its details. And we are going to see it now. So, an important symbol of this curve is the z-score that is shown here. Okay. I'll explain how this table is used. But basically, if you look at what the z-score is, it is the number of standard deviations. Okay. That means how many standard deviations is it from the mean. So if you take the diagram or the normal distribution curve, Usually, so this is mu, this is the mean, okay? So this basically is the mean, right? Is the mean. Now where this Z is basically the gap between the mean and the x-axis values. That means this is the x-axis now. Okay, and there's a value here. There are values here now. Let's assume these two values. Okay, and this is let's say x1 and this is x2. So the difference between the mean and x1 is equal to z. Okay, and the difference between the mean and x2 is also equal to z, because z is equally divided, but no, but not in all cases. Okay, because some cases what it no, it does get, of course, wait, let me clear this. It gets equally divided if it covers the whole area under the graph. Okay, so this gap, remember, what you should remember is the gap between the mean and the value of x is only equal to z. And the standard, so they divide it by what you call the standard deviation, which is given in the question. And you see x is the value of the variable under consideration. Z is the number of standard deviation. That means how far x1 is from the mean. Okay, this is what it means. Alright, so when we do the question, you will perfectly understand what I told. So if we look at this table, now say we need, now this column that you see below represents values of z. Okay, and this side also represents, the horizontal line also represents, see the cursor where I am taking it. It also represents value of z, the one that is highlighted in blue. Okay, and this set of numbers under the graph, see the cursor, these numbers are the probabilities or the area under the graph, which is, I'll show you, this part. Okay, this area under the graph, right? Okay, so for a particular z value, let's say the z value is, for example, z is 1.9, 1.98. Alright, the gap between mu or the mean and the x1 is 1.98. Then find the area under the graph for a value with a gap of 1.98. Then what will be the answer? Now how to find 1.98 in this table? Z dot E equals to 1.98. So there isn't, right? If you look at the vertical column, the 98 is not there. Up to 1.9 it is available, isn't it? Z equals 1.9 is available. Okay. The reason for the horizontal line I am going to explain. This horizontal line represents the decimal values of the Z component. So now we are looking for a value of 1.98 from this table. where z equals to 1.98. Horizontally, we will find the big number 1.9. Balance two decimal places, we should look it in the horizontal line. So this 0.08 plus 1.9 will give us 1.98. If you check and see 1.9 plus 0.08, how much? 1.98. Therefore, you should come this side, see where my cursor goes, this way straight, and from 1.9 onwards go horizontally to meet the value 0.4761. Okay. This is basically the probability of data under the curve with a value of z 1.98. So if I am to show it in a blank diagram, this will be the mean. Now I said the gap between a particular x value. Let's say the x value is here. Now I'm going to say the x value is here and the gap between these two is only z of 1.98. Okay. Now if you take a graph paper, students listen well. If you take a graph paper, if you take x2, the gap between x2 and the mean, the z value will be a higher value, right? Because mean is here and the x2 is here. So the gap is more than the gap between x and the mean. Okay. So we understand that logic. So that's why z can be any number. That's why they have given a table of values for z. Up to maximum it can be up to 3.5 or more than that also we can use the formula. Fine. So the x value is basically the normal distribution data. Alright, it's the normal distribution. And this is the mean and this is the standard deviation, but z is the number of standard deviations. Okay. So 1.98 is this gap between mean and the x, not x2. X, where is it stopping? If you put a line like this, it is here, stops here, right? Now this 1.98 is the gap from the mean. It is not the gap from anywhere else. It will never ever be. It will always be the gap from this middle value mean. Therefore, the answer that we got 0.4761, if you convert that into a percentage, 0.4761 multiplied by 100%, you will get 47.61 percentage, isn't it? Right? So you will get 47.61 percentage. This is the probability of data represented under this section of the curve. So only this section, see, only this section is 47.61. Okay, only this particular section up to x value. Why? Because we thought that the gap between the x value and the mean is 1.98. So, if we are going this side 1.98, distance of 1.98. Now I told you gap between any value and the mean is always z. So we'll say this side 1.98 of z. How do we mark it? I'm going to say this is the minus x part or something like that. Right? I'm going to reduce it a bit up to here, the gap. Then if this side also is 1.98, that means this is also equal to 47.61 percentage. 47.61 percentage. Okay. So see, this side also if you go 1.98 and this side also if you go 1.98, you will get the answer of area of probability. That means the data represented under this section is 47.61. But if you go more than this x value, if you choose up to here, a value up to here, we'll call this x1. Then there's an extra portion, right? This portion. Isn't it? Then there's an extra portion, right? This portion is extra. Isn't it? Now this one we already found 47.61. What is this portion? Then you should find the mean, the gap between the average and this one, and then minus and then get the area of this whole section and minus of this particular section's area. Then you will get balance of this. Okay.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.